Chapter 12, Number 25. On Apollo missions to the Moon, the command module orbited at an altitude of 110 kilometers above the lunar surface. How much time did it take for the command module to complete one orbit? So, just terminologically, the distance we're going to care about is the distance to the center, which I call little r. We're going to say the Moon has mass capital M and radius capital R, and we're a height h above the surface, where that's h. So we know that we can basically use Kepler's third law, which says that t squared is proportional to r cubed, but I don't have the proportionality. We could look up Kepler's third law, but I also want to point out that we can derive it relatively quickly by saying that the gravitational force must provide the centripetal force. So g, mass of the Moon, mass of the rocket, over the distance squared has to be the same as m omega squared r, but omega was 2 pi over t squared, and we get r. And so we have g, the mass of the rocket will cancel out. So we'll have just gm over r squared equals 4 pi squared over t squared times r. Or t squared is, solving everybody else over, 4 pi squared r cubed over gm. So that's Kepler's third law, and what we're going to do is say that the period that we want is the square root of all that stuff. So it's going to be 4 pi squared times the distance, which is 110,000 meters, plus the radius of the Moon. According to Google, that is 1.74 times 10 to the 6 meters, and then cube it, over 6.67 times 10 to the minus 11 Newton meter square per kilogram square times the mass of the Moon, which Google tells us is 7.35 times 10 to the 22 kilograms, and then the square root of all of that. This turns out to be 7140 seconds, which, if you convert it, is 1.98 hours. So roughly every 2 hours they went around the Moon once.